back to another episode of Sunday Science. Today, our fellow friend Aditi has gone out of town. So, to replace her, we have our new friend, Sanvi R.
Hi, guys.
Guys, do you hear that weird noise?
Hear what?
The weird bird noise.
Yeah, it is a weird bird noise. But have you ever wondered, what is sound? And how do we hear it?
Let's find out on today's Sunday Science.
What is sound? Well, sound is all around us and has many different names. Annoying sound, like traffic, is called noise, while sound made by instruments is called music. But truly, all sound is created in one way, through vibrations. Vibrations are nothing but movement of an object back and forth really, really fast.
We hear sounds through our ears. Take the sound of a bell ringing. When you ring the bell, it vibrates. The vibration also shakes up the air particles around it. The air particles run into other air particles, and so on. When the sound reaches all the way into our ear, it makes it to the eardrum. The eardrum vibrates, sending a signal to the brain, and the brain interprets it as the sound caused by the ringing of a bell.
Today we'll be doing an experiment to display the vibrations of sounds. For this experiment, you will need a metal cup or a can and an elastic rubber band.
Put the rubber band vertically around the top. Make sure that the band is tight and secure and it goes across the cup's diameter.
Hold the cup at its edges and stretch the band backwards. Let's start with doing this lightly. You will hear a light sound made by vibrations. Then do it again, but harder. You will notice that the sound created is significantly louder than last time.
You can also try pulling the band and stopping it when it is vibrating. This will stop the vibrations and then end the sound.
Now we're going to do an experiment showing how different types of materials make different types of sounds. Let's start the experiment.
First, get 3 different materials. We have 3 different types of objects. We have a wine glass, a metal water bottle, and some toilet paper. You will also need a pen or stick for this experiment.
Then take the pen or stick and hit all of the things very gently though.
Well, as you can see, all of them make a little bit of sound, but the metal one makes a much louder and prominent sound than the others. This is because metal is much harder than the others.
The harder the material, the more vibrations it will make and the louder the sound will be, which is why metal made a louder sound. Glass is not as hard as metal, but it is more harder than the toilet paper, which is why it made a sound, but it wasn't that prominent.
Sounds can be quiet as the rustling of wind and as loud as a boom of plane. Sounds can be pleasant like music or as annoying as traffic. What makes sound different from each other? The answer to that question is pitch and loudness. The pitch of a sound tells us how shrill or deep it is. It depends on the vibrations of a sound in 1 second, that is, the frequency measured in hertz. The greater the frequency, the higher the pitch. The loudness of sound tells us how loud or soft a sound is. The loudness of sound depends on the amplitude of the vibrating object. The larger the amplitude, the louder the sound. The pitch and the loudness of sound is different. The pitch of a sound depends upon its frequency, while the loudness of sound depends upon its amplitude.
Do humans hear all sounds? Well, the answer is no. Humans can only hear up to a certain level. Humans can hear from 20 Hz to 20,000 Hz, which is called the audible frequency range. Some animals that hear above the audible frequency range, otherwise known as the ultrasound range, are cows, dogs, and horses. And an animal that hears below the audible frequency range, also known as the infrasound range, is an elephant.
As you can hear, this music is really shrill and high-pitched.
We want the music to sound a little more clear, so to combat that, we've made a speaker out of household items like this.
We made this speaker using a paper tube, a paper cup, 2 paper cups, and a bunch of paper towels. First, we took the paper tube and cut a slit on the top, or the bottom, doesn't matter. Then we made holes in the cups and put the tube inside of it. Then we put the paper towels and stuffed the paper towels into the cups.
Wow, this speaker makes this music sound more like the original.
How this speaker works is when the sound waves enter the paper tube, they bounce up and down. Once they exit the paper tube, the paper towels absorb the high frequency and give us the music that was originally recorded. Wow, that was so interesting.
Yeah, I thought that was super cool.
I really like that homemade speaker. I'm definitely going to try that.
Same.
Thank you for watching and see you next Sunday on Sunday
Sunday
Science.
Science.